This is Logus, and I will be taking you through Unit 5.0, which is all about trig identities. Unit 3 was about just starting trigonometry. Unit 4 is about graphing trig functions, and now what we're going to be doing is looking at identities, which are equations or expressions that are always true. We're going to use them to solve a lot of problems throughout the unit. And so the first thing I'd like you to do is have your Unit 5.0 packet in front of you, and that whole first page has the list of every identity we're going to be using, and I'm going to be going through some of them in detail at this time. So if we take a look first at these reciprocal identities, things you already know from Unit 3 and 4, that sine and cosecant are reciprocals, that cosine and secant are reciprocals, and tangent and cotangent are reciprocals. The reason this is useful, and will come up later on, is let's look at sine and cosecant, for instance. Let's say I gave you that sine of theta was equal to 1/2. That would mean automatically that I can find the reciprocal. The reciprocal of sine is cosecant of theta, and the reciprocal of 1/2 is 2/1. So if I know that sine of theta is 1/2, I know that the cosecant must be 2. If I looked at tangent, the same would be true. Let's say I gave you cotangent this time. Let's say that I said that the cotangent of theta was equal to √2. That would mean that the reciprocal, or the tangent of theta, would be equal to, well, this is really √2/1, so the reciprocal will be 1/√2, which, if rationalized, would be √2/2. So this skill is going to be very, very useful coming up soon. The quotient identities is something else you already somewhat know. If you think about all that time we spent on the unit circle, and we had a little right triangle here, we had a point x comma y, and we said that this distance was x, this distance was y, and from Unit 3 we determined that x was also represented by the cosine of theta, y was really represented, or y values, as the sine of theta. We said that tangent of an angle was equal to y/x, so it would only make sense that if y is represented by sine and x is represented by cosine, that tangent of theta must be equal to sine over. And so that is one of the quotient identities, that tangent equals sine over cosine, and this is what we're going to be using a lot later in the video. It would also make sense that the reciprocal function of cotangent has to be cosine over sine, because if sine over cosine is y/x, this must be x/y. The next type of identities are very handy indeed, the Pythagorean identities. Now, the reason they're called Pythagorean is because, yes, it's based on the Pythagorean theorem, a² plus b² equals c². Now, this also relates back to that unit circle that I just drew. If you think about the unit circle, the reason it was called the unit circle is because the radius all the way around was 1 unit. And again, we made this little triangle here. And we called this cosine of theta and this sine of theta, just because what we just talked about, the x and y values. Because this triangle had to be right, because the y value was perpendicular to the x value, we could apply the Pythagorean theorem, that x² plus y² equals 1, or sine² plus cosine² equals 1. And so this identity here is extremely helpful. It comes up so many times in this unit, it's very much worth memorizing at this point. If you'd like me to prove it to you via algebra as well, let's say we're talking about this unit circle and we're talking about 30 degrees here. The point on the unit circle was √3/2, 1/2. So let's see if this identity holds true. The x value would be √3/2, because that's the x here. The y value would be 1/2. So let's see if it equals 1. Does the y value squared plus the x value squared equal 1? Well, if I square 1/2, you square the top and the bottom, so that will be 1/4 plus √3² is just 3, 2² is 4, 1/4 plus 3/4 equals 4/4, so 1 does equal 1, so yes, this identity does hold true. Something else that does hold true are the two identities down here, and both of these identities are versions of this original sine² plus cosine² equals 1. Now, it's tempting to say, oh, another thing to memorize. The good news is that you don't technically have to memorize these because they both involve a similar process from the original. So this first one here, what if I decided to manipulate the original equation? So I'm going to write sine squared theta plus cosine squared theta equals 1. I'm allowed to do the same thing on both sides of the equations if I wanted to. What if I decided to divide everything I saw by cosine squared theta? If I did that, sine squared divided by cosine squared is the same as sine divided by cosine. Sine divided by cosine is tangent, so this would become tangent squared theta plus cosine squared divided by cosine squared is 1 equals 1 over cosine squared. Now, excuse the jump, but if I go back to that first slide, think about reciprocals. If I have 1 over cosine, that is really the same as secant. So that means here, 1 over cosine squared is really secant squared theta. And that is the identity here. If I look at the one in red and I copy down the original Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Last time we divided everything by cosine squared. I bet some of you are predicting that this time I'm going to divide everything by sine squared theta. Notice the 1 there, it would make sense to divide. If I divide every single thing I see by sine squared theta, here's what I would get this time. Sine divided by sine is just 1, plus cosine divided by sine is the reciprocal of tangent, so it would be cotangent squared theta equals 1 over sine. Well, 1 over sine is secant or cosecant, so 1 over sine squared would be cosecant squared theta, and that is the other identity. So what you really need to do is just memorize this first one, and then you can just manipulate to get to these two. Now the cofunction identities, these have to do with a right triangle. So what if I drew one over here? Let me draw a right triangle using the unit circle again, common theme. Let's say I have a 30, 60, 90 triangle, and from the unit circle I know this is 1, this is 2, and this is root 3. That's also from the special right triangles in geometry. So here's what these problems are saying, or these identities. Let's say that the theta that I'm thinking of is 30 degrees. We want to see, does cosine of 30 equal this side? Well, from unit 3, we know that pi over 2 in radians is really 90 degrees. So this is really 90 minus 30 degrees, which is really 60. So we're asking, does the sine of 60 degrees equal the cosine of 30 degrees? Well, let's look at this triangle that I drew and see if it's true. If I look at the sine of 60, we're looking from this position. Sine is opposite over hypotenuse, so that would be root 3 over 2. So this is really root 3 over 2. If I change colors and look at the 30 degrees this time as my reference angle, the cosine is adjacent over hypotenuse, which again is root 3 over 2. So what's interesting about the cofunction identities is that if you have any right triangle, notice that every single one of these has a pi over 2 in it. Because a right triangle already has a 90-degree angle, that means that these two angles together must equal 90 degrees to complete the triangle to be 180 degrees. So if I keep things general and call this angle x and this angle y, I know that x and y together have to equal 90, and it also means that this opposite relationship holds true, that if I find the cosine of this angle x, that is going to be the same as the sine of the other angle y. And the other way, if I wanted to find the sine of this angle, that means it's going to be the same as the cosine of the other angle, because you're looking from a different perspective, but you're dealing with the same three sides. So the next identities are the even and odd identities, which yet again have to do with the unit circle. So what I did was I drew a picture, and I drew the favorite triangle of all time, 30, 60, 90, and then all of these have to do with a positive theta and a negative theta. So if in the first quadrant you're dealing with the angle going upwards like this, The negative theta means you're going in the opposite direction, so negative 30 degrees. So notice that the points that I drew from the unit circle. If I have this top triangle in the first quadrant, my coordinate is both positive. If I have my triangle flipped over because I went backwards instead, which is really clockwise, my y value is negative. So if I calculated some of these values, the cosine of positive 30, this distance, is a positive root 3 over 2. And the cosine of negative 30 is also a positive root 3 over 2. So that means that if I plug a negative angle into the cosine function, the value ends up still coming out positive. However, sine. The sine of 30 degrees is this distance of y, which here is a positive 1/2. So the sine of 30 is 1/2. However, the sine of negative 30, if I go this direction, would be negative 1/2. So that means that if I plug a negative angle value into the sine function, the entire function becomes negative, or the output value is negative. Lastly, just to touch on tangent, these would all make sense and follow suit because of the reciprocals. But if I look at tangent of negative theta, it would make sense is sine of negative theta over cosine of negative theta. We know that sine of negative theta is negative sine of theta. Cosine of negative theta is equal to cosine of theta. So it would make sense that the tangent value is also negative. So these identities here, sum and difference and double angle, we will go over later in the unit when they apply a little bit more frequently. But for now, I'd like to get to the last couple examples. Use trig identities to evaluate the remaining trig functions given. So I have 2 of them. So I want to find the reciprocals, use some of the identities we talked about to help us find all 6. I would say the easiest 2 to find right now are the reciprocals of the ones given. The reciprocal of tangent is cotangent, and the reciprocal of root 3 over 3 is 3 over root 3. Now, because I can't have a radical in the denominator, if I rationalize that, I would get that the cotangent of x is really equal to 3 root 3 over 3, which is just root 3. If I know that cosine of x is negative root 3 over 2, that means that secant of x, the reciprocal, is equal to negative 2 over root 3. But just like last time, if I rationalize and multiply top and bottom by root 3, I get that secant of x is equal to negative 2 root 3 over 3. Now the last 2 I need to find are sine and cosecant. Now without drawing a picture, here's how we would use identities. I know that tangent of x is equal to sine of x over cosine of x. So what's nice about identities is that they're always true. And if I want to find for sine, let's solve for it. If I multiplied both sides by cosine of x, I know that if I want to find sine of x, it's equal to cosine of x times tangent of x. Luckily for us, I know both of those values. I know from above that cosine of x is negative root 3 over 2, and I know that tangent of x is positive root 3 over 3. So if I multiply that, I would get sine of x equals negative 3 over 6, or negative 1/2. And that would follow that if sine of x is negative 1/2, that means that the reciprocal function cosecant of x would be negative 2 over 1, or cosecant of x is just equal to negative 2. So there we found all 6 trig functions. So this last problem, I want you to try sum on your own, but first I want to point out that this is an identity. If I know that cosine of pi over 2 minus an angle is 3/5, if I go back to this slide here, cosine of pi over 2 minus an angle is the same as the sine of that angle. So that this identity can be rewritten as that the sine of theta is equal to 3/5. So I know this is true, and I know this is true. So what I want you to do is try to find the reciprocals of these 2 first, and then use the tangent identity to find more. I will be back with my work. Please try it on your own now. Here were my final answers. Tangent of theta equals sine over cosine. which was 3/5 divided by 4/5, which I simplified to be 3/4, and so that means cotangent is 4/3.